Hello, everyone. I'm very happy to be here and tell you about the work we do in our research group. So, okay, sorry. Yeah, so our mission is to develop new AI algorithms by studying natural intelligence, intelligence that runs in our brains. And of course, you might ask, why bother? Why should we care about this natural intelligence, given that we have already these algorithms? You have seen some of them, but here's a convolutional neural network that is perfect at categorizing digits. We have networks that can categorize objects. We have networks for machine translation. Why bother with this natural intelligence? However, one problem with all of these networks is that they require extensive training. So you need millions and millions of examples for setting up the network. And then, if you look, for example, at this convolutional neural network, it can give you a quick answer, which is nice. And if you need a quick, simple answer, it's very good. However, that's not what you want in your business, or that's not what we want from intelligence, right? Rather, we want our AI or our employee to solve tasks that are novel, right? I mean, that's why you do your business, for example. You want to develop some new software or some new solution, not find a quick solution to a problem that everybody has done millions of times, right? So you would like to have these kinds of AI systems that can solve these kinds of tasks, and rather than come up with some quick and stupid answer, you want them to really kind of think or search for an answer. So think about it, how you would solve your problem in your business, or when you're coding something, or whatever you do, right? It's not that you come up with the first answer, but rather you try different possibilities. You come up with different ideas that you could somehow combine. Not all of these ideas are good, so the other step is that you actually refine it. So you make many possibilities, you refine this search space, and you do this in many steps. So the question we are faced in our research is that how can we actually create AI algorithms that do something like that, that create these possibilities and refine them. And remember, in my research, I'm not only interested in developing these AI algorithms, but I also want to understand how it works in our brain. So we want a task for studying this where we can basically compare the AI algorithm and the humans, and as we're doing basic science, then we want a task that is as simple as possible, while still keeping these key ideas of creating possibilities and refining them. So here's the task. Your task is to find an everyday object that is somehow hidden in these dots. And when you see this, now you might think, what does this have to do with the introduction I just gave about creating possibilities and refining them? But if you actually start to do this task, then you see that in your brain what's happening is you are trying out, is it some kind of an animal? Is it some kind of a fruit? I mean, you're not doing all of that consciously, but many of these hypotheses you are considering kind of come and go. And then you might refine it and find that, okay, here is, for example, some line, here's another line, oh, this might be glasses. So this is a simple task. However, for us, it keeps the key elements of this problem we want to solve. And we can use this task and test it on both humans and AI algorithms. So here's a slide about how we actually do this stimuli. with today's machine vision algorithms, we can actually do hundreds or thousands of these kinds of images, because we can take everyday pictures of everyday objects, and then with machine learning algorithms, basically cut them into parts, segment them, and then the rest is already relatively easy. So the point is, we can do many of these things, and then we can run experiments with them. So here's an experimental data from humans. Sorry for that. I don't know why this is the case, but the point is that the human is presented with an image like that, and then we say, look, try to tell us what you see here, and draw what you actually see. And here, the subject then first thinks, oh, it is a grab. It is some kind of a grab there. Hey, when I actually think about it, no, it's different. It's a grab like that. And then the human says, oh, now I see. It's a cat. Right? So you see what happens when humans do this experiment is exactly how I told you. They consider many possibilities, and then over time refine them. And what's interesting is always that often this solution then in the end comes with this big aha, now I know. So, but how can we create AI systems that do something like that? Here I will present you a work of two talented PhD students, Taavi and Tarun. So essentially what we want is we want to give the same images to the AI system, and we wanted to create these possibilities, which many typical AI algorithms don't do, and then we wanted to refine it over time. So the real object embedded here is a hammer, but the way our AI algorithm does it is by something that is called an evolutionary or genetic algorithm, which means that at first, this algorithm tries to come up with something. So some lines, as you see there, some line combinations that somehow match or cover these dots. So, and it makes many possibilities. At the next step, we use a pre-trained neural network clip to evaluate these sketches. So note that we haven't trained the clip on these images. So it's not that our neural network is trained on these images and on this problem. Rather, it takes some of the solutions and then evaluates them. Thinks, okay, yeah, this is a pretty good idea, or that's a bad idea. And then in the next step of refinement, we throw out bad possibilities, and then with the good possibilities, we keep on adding new lines to it. And then we do it in many, many iterations. So, of course, I'm not claiming that this is exactly the algorithm running in our brains. But I'm saying that this is already a step closer to the algorithm running in our brains, because it generates these many possibilities and refines it over time. And of course, the hope is that then eventually it would come up with something like that. So indeed, this algorithm can sometimes have a solution like that. It can actually catch almost the right lines, almost the right dots, and label it actually as a hammer. However, as some of you who work on these AI algorithms know, often the problem is that their performance is not really consistent. So for example, when we do a different run with this same image, then the AI converges on something like that. And now you would say, oh, this is completely random, what's that? But the AI tells us this is a box. And now, if you look at it, yeah, it is kind of a box. However, no human ever would draw a box like that, or Or is it something artistic? We do have many examples like that. For example, again, the algorithm claims that this is a torch, and yes, it kind of has the essential elements of a torch, but it is a very, very abstract torch. And when we looked at many of these examples, we worked with many of these examples, then we kind of saw that this is a problem that the current algorithm we are using has, and we call it the Picasso mode. Because essentially it is providing us this very abstract solution sometimes. So this Picasso mode here is not a compliment, right? It's not that it is great artistic, but it's saying that it's offering us something that is very abstract, too abstract. So if we, in the beginning, saw that today's AI is too narrow, it provides only one solution to a problem, then now we can also see that sometimes it is too wild. And of course, if you have a business, you want the real working solution, then you don't want anything that's too narrow or too wild. You want to be on this sweet spot between the wild and narrow. You want to be at the sweet spot of natural intelligence. Thank you. And that is where our work is. And over the next years, we hope actually to provide AI solutions that can do this, that they provide results that are creative, but that on the same time make sense. And of course, we will do it by creating many possibilities of these algorithms, refining it over time, and hopefully not getting into the Picasso mode. Thank you very much.
All right, thanks a lot for the presentation.